So I like to talk about how SDN NFV really can help you to set up and to manage enterprise networks in a new way. And let me start with what triggered the definition and the founding of Jena. It was a very simple finding that all our enterprise and business customers are truly internationally. Most of them are even global. And secondly, that with the change in IT industry, in the cloud paradigm, the public internet needs to become an integral part of any kind of enterprise network architectures. So it's truly hybrid, needs to be truly hybrid to integrate public cloud platforms, and it needs to reach more or less out to more or less every location in the world. As we all know, our current networks with classically designed networks, MPLS-based with classical service providers, are not perfectly architected to fulfill this kind of use case. Now, there needs to be some new idea how to do it, and that was the reason why we founded Jena. Jena, in the first place, is an abbreviation and stands for the Next Generation Enterprise Network Alliance. So in the first place, it's an alliance of leading telecommunication companies around the world which have strong network assets. If I talk about assets, I primarily refer to access and aggregation networks. And all that service providers are strong in a country or in a given region. And the simple idea is, if you connect the strong networks of the so-called alliance partners, and if you build an SDN NFV kind of platform which is connecting these local assets, meaning the local networks of the alliance partners, you can build a global platform which would allow you to deliver enterprise-grade services to more or less any kind or any place around the world. So what we are finally doing is we are converting or transforming the local assets of the service provider in a single overlay network and have a bunch of additional services which helps the alliance partner to sell fully fledged enterprise-grade networks to their customers. That is what is really behind Jena. And we are using this NFV SDN technologies to build that kind of global platform. Now, having said that, how does the alliance look like as of today? We are now more than 20 partners in that global ecosystem. And you find, and I can't walk you through, but you will find, for example, KPN here on the slide, more or less being here the hosts in the Netherlands. You find CenturyLink here. Claudio will talk a little bit later, also as a speaker in that session. You find one of the key hosts with Deutsche Telekom here for the Congress, but we also have very strong Asian players like China Unicom, like Viatel, StarHub, and so on. So it's really covering completely Europe, Asia, Africa, and North and South America. So we are very comprehensive, and we have really achieved global coverage already. Next to the service providers, we also, because we truly believe in a strong ecosystem play, have very strong technology partners, which helps us to build that platform. Just to mention the most important ones, which is Cisco. So our technology, the core technology, is based on Cisco Viptela technology as a SD-WAN prime technology, and added with a lot of further functionalities in security, application optimization, and others out of their portfolio. And on the IT stack, we work primarily with Comarch, a Polish company, which is quite strong in the OSS, BSS. The whole platform is completely end-to-end automated across the whole stack. And Equinix is another strong partner of ours, which we use for data center services, but especially also for their cloud exchange platform to connect to any kind of cloud services, infrastructure as a service platforms like the Amazons and the Microsoft and so on, as well as the SaaS services. So that is a rough overview on the ecosystem. Looking a little bit deeper into how it really works, let us have a short video.
NGENA provides a global platform that interconnects the local networks of all its alliance partners, forming a single software-defined network. With NGENA's shared network, local alliance partners can deliver consistent data connectivity services to their end customers on a global scale. To manage the software-defined network, NGENA has developed a global platform to deliver truly hybrid VPN solutions. Leveraging the advantages of virtualization technology and automation, NGENA facilitates a flexible end-to-end configuration and provisioning of all services. For each customer site, alliance partners can offer a choice of single or redundant low-cost internet lines, single or redundant high-quality Ethernet lines, or a combination of internet and Ethernet lines. NGENA's innovative approach centers around 1. A global alliance of leading telecommunication providers. 2. A software-defined network providing hybrid VPNs for enterprises. 3. An end-to-end automated service orchestration. And 4. A central portal supporting all business and operational processes. With the NGENA approach, alliance partners and their customers can realize significant business benefits.
Okay, what I want to focus today on very much is really what are the services we are providing on that global platform. And as a more or less a framework, or before I dig into more detailed services, it's about the core service is a VPN. And the architecture is built the way that we are more or less running 20 data centers around the world. So have our infrastructure there. And at each of the data centers, we connect into the networks of our alliance partners. We run our own backbone, so data centers and backbone provide what I call the global platform. There is, from a network architecture point of view, then an any-to-any connection to any of the customer sites around the world, traveling via our hub infrastructure and backbone to any other location of the customer. We run, of course, quality of service, class of service on our network, and it has an end-to-end encryption. So there's only encrypted traffic, and it's end-to-end encrypted from any side of the customer to any other side. There is a clearly described and defined SLAs coming with services, which has to do with the support times, availability, and others. Of course, they are not harmonized around the world because you don't get everywhere the same SLAs, but for each location, meaning each region or each respective area, there's a clearly defined set of services, of service SLAs. Very important is, as already mentioned, the whole service is managed from a global service catalog. So all services which are available in that service catalog. Every of that service is comprehensively described in a data model. We are using young data models here. And it can be selected and completely automated deployed via layered service orchestration on that global platform. So you have a solution designer where you design your global solution, hundreds of sites, additional services, and you create a comprehensive service model for your enterprise network. And the deployment then is done via several layers of orchestration. We are working up to 4 layers of orchestration here, without anybody anymore looking into the detailed architecture, because it's all defined in the data models completely automatically down to the configs of the CPs. This is the way how this is really implemented. Now, looking into how our service catalog looks like, and I want to build it step by step. So the core of the service catalog is what we call the access designs. This is the way how we connect in a standardized manner customer locations to the platform and finally to the enterprise network. We have chosen a very simple way of naming it, from a very small, extra small design to an extra large design. And it's a combination of private links and public internet links. Now, how it looks in a little bit more detail, you find here. So the extra small design is a single internet link. What you always see here is our data center sites. We call them Jena hubs, or have always completely redundant infrastructure for resilience reasons. Here you see the rough architecture, how it is connected. So it's a customer sites, it's a single internet link, which then is in a redundant manner being connected to one of our hubs. Of course, the nearest hub is chosen here. Now, the small design works with a redundant internet link. The so-called medium-sized design is a combination of a private line, an Ethernet link, and an internet link. And the L and the XL designs are redundant Ethernet links. The difference between L and XL has to do with diversity on the line connectivity itself. This has been our initial designs. We have learned from the first customer projects that there have been some additional requirements. For example, we have introduced not just a single, if you see the comparison here, not just a single CPE at the customer site for the S and the M design. So we also now have a standard design with redundant CPEs at the customer site. We also have a pure replacement for the classical MPLS link, just one Ethernet link. And of course also for the data center sites of customers or large headquarter sites where you want to do internet offloading as well. So there's also now a combination of redundant Ethernet links with 2 additional internet links. So we found that with this now 10 designs we have defined, we can more or less fulfill any kind of customer requirements, customers' RFPs we have currently seen together with our alliance partners. So this is a basic set of services we have. Very important, of course, is also that there is a capability to connect to existing other layer 3 networks, because all the customers have networks, and for transformation from existing environments to the Jena platform, of course, there needs to be a standard way of connecting. So we are supporting the CE-CE coupling at customer site, for example, data center sites, wherever it is, or a standard way of connecting an alliance partner CPE in a redundant manner to one of our Jena hubs. So there are 2 different ways, more customer-centric versus more provider-centric standard connectivity, as it is very usual in our industry. So there is an easy way, standard configuration to connect to any other layer 3 network. Another very important part, of course, is providing transparency and visibility. So a comprehensive dashboard showing all the relevant parameters for any kind or every customer site is part of that offering. So here is the vManage dashboard, just as one of the ways how we expose this kind of transparency to alliance partners and to end customers, where you see whether all of your equipment is up and running, whether you have some problems with the control tunnels, or whether your performance, meaning zeta, packet loss, round-trip delay times are within the expectation or not. So it's real-time monitoring of every site around the world being shown in one single dashboard. The next important piece here, of course, is that all the enterprise networks needs a quite comprehensive set of value-added services. And we have categorized it into 3 categories. the advanced network services, application optimization, and advanced services. So there's already a significant set of services available. In the security, we are, amongst other services, are offering virtualized firewalls. We're using Cisco Other here, or the web security appliance. In the application optimization, there's an automated recognition of the types of application. We are using the Cisco NBAR technology here. And of course, there is a class of service and multi-VPN and so all the, I would say, advanced features which typically come with the SDN and NFV, meaning SD-WAN architecture available. Now, having said that, one of the most important additional services, of course, is how you can integrate the public internet into your access design, not just using public internet as a means of connectivity and being part of a corporate network, but also to do secured internet breakout services. We do that in three very different ways. We can do that at the hub side. We call it regional internet breakout. We can do that via the cloud security services. We are working together here with Zscaler or with a local internet breakout at the customer site. And to give you some more insights into that one, so the regional internet breakout works with a dedicated service chaining of a firewall and a web security appliance to protect against the internet. The local internet breakout via the security cloud provider is an automated workflow setting up the respective IPsec tunnels to the Zscaler clouds to the nearest ones, and then of course using their set of services to protect against the internet. Fully automatically, the whole workflow is implemented. And to do the local internet access on a standard or classic CPE, it comes with a zone-based firewall, which runs on that CPE. So it's a stateful firewall. And even in a more advanced setup as a local internet breakout, we support the universal CPE, which is a Cisco ENCS platform, which comes with a full-fledged other firewall and the web security appliance, which then from an architecture is very much the same way how we protect against the internet on the hub as well. So it's the same way of service training we are doing here, but just at the customer location on a universal CPE. So this gives you an idea about the set of services. And last but not least, connectivity to public cloud platforms is extremely important because nearly all the customers are asking for it. And there are two ways of doing it. One way to connect to the infrastructure as a service providers, primarily the Amazon Web Services and the Microsoft Azure. We are ramping up a virtualized CPE, VH Cloud, at the local instance of the customer in the ES infrastructure, so in the VPC. And there's an automated workflow how to do that. And then the virtual infrastructure on the VPC becomes an endpoint of the corporate network. So you terminate the encrypted tunnel directly into that environment of the customer. That is one way how we do it. And the second way, if you want to connect to the software as a services, so the SaaS services, of course you can't fire up a virtualized router in a SaaS environment. So we work here together with Equinix and use one of their NFV infrastructures they are building to ramp up our virtualized routers there to terminate the tunnels and then to use the Equinix Cloud Exchange platform, which is reaching out to 30 plus leading SaaS platforms around the world to really get end-to-end connectivity and make it an integral service of the Jena platform as well. Now, This now gives you the comprehensive overview on the service portfolio which is available with Jena, because we believe that our alliance partners, if they want to sell to their customers, it needs to be much more than just the connectivity piece, because it needs to cover the customer requirements for real enterprise-grade networks and a significant bunch of additional services, which needs to be simply part of what customers currently are requesting if you want to serve them according to their expectation. That's it, and I won't leave it here to stay and within my time budget. Thanks a lot.